On this great day, what we want to do here is we're going to talk about using properties. First off, we want to know what those properties are of perpendicular and angled bisectors. So let's follow these instructions, and then we're going to define an angled bisector momentarily here. So first I'm going to draw AB. So many of you drew AB, and it probably drew something like this. So we just mark it with an A and with a B. Ka-chow. All right, now we're going to mark the midpoint M. Now, we're going to mark it. It's got to be somewhere in there, but what's the key thing about it? Ka-chow. We have to have those marks. Next, now we're going to draw and mark or draw and label the perpendicular that goes through M. So it's not going to be this. That doesn't count. So, what? All right, so it's going to look something like this. So this is just an approximation, and I'm going to label that. I've got to make sure that it's marked like so. So there's my perpendicular bisector. Right there, I've done that. Now I'm going to draw P. Where? Doesn't matter. You can put it here, or here, or here, or here, or here. I'm going to put it way up here because most of you probably did something like that. There we go. Ka-chow. Now I'm going to draw BP, which is this. And I'm going to draw AP, which is this, or segment. Yay, we're all there. Now, why are these two triangles congruent? This one right here, this one right here. So we see that these two triangles are congruent by side, angle, side. Which two here? This is reflexive property. Right angles are congruent, and this because we're given information. Great, so now what's true about BP and AP? Well, they have to be congruent because of why? What 5 letters? C to the P to the C to the T to the C. Boom! Now, number 9 is kind of a funny question, but does it matter where P was? What if you put P right here? Does it change anything?
No, segments are equal.
It still has reflexive properties, still has right angles, and it still has that. So P can be anywhere on this line, and these two are still going to be congruent. Now, that doesn't mean this is going to be congruent like had I put P down here. I'm not saying that this guy is congruent to this guy. I'm saying that these two are going to be congruent. These two are going to be congruent. So the short answer over here is no. All right, so what does it mean to be a perpendicular bisector? A perpendicular bisector, we have to have a right angle in there, and we have to have a midpoint. That's what makes a perpendicular bisector. If a point is on the perpendicular bisector of a segment, then it is, here's a great word for you, equidistant. Let's say that again. Just let it roll off your tongue. Equidistant from the endpoints of the segment. Turns out that the converse is also true. So take a moment with your partner. How would you converse what we just said up there? All right. Good. So if a point is equidistant from the endpoints of a segment, then it is also on the perpendicular bisector. By the way, is there something else that's true? So notice using CPCTC, we said this is true. Is there anything else that's got to be true using CPCTC? Good. So now the theorem doesn't say that, but you can extract it from the theorem pretty darn quick. Is that you can instantly see, look at this. Wait, so what kind of triangle is this big triangle right here? It's an isosceles triangle. Right? Look, and the base angles there are congruent. And what happens when you draw the perpendicular bisector? Oh, look, it also bisects this angle. There's all this crazy stuff that we find out just because of C to the B to the C to the C to the C. All right, so let's take this and see how it applies. So we're going to find some missing lengths, etc. here. So according to the diagram, MO, so which one is MO? This one is MO, right there. Which segment does it perpendicular bisect? Well, it's perpendicular bisecting this blue one right here. How do I know that? Because we have perpendicular mark there, and we have a congruence mark there, which means this Q is the midpoint of NP. So MO is the perpendicular bisector of NP. As a result, I know a bunch of things are true. So how big is MP? Well, MP is right here, so it's the same length as over there, and I'll put a double mark on that, so that's 4.5. What else do I know? NO is over here, NO, so it's going to be congruent to that one, so that's going to be 9.5. And what about NP? Well, how the Gehenna are we going to find NP? How do we find NP? Well, we actually have 3.2 right there, so 3.2 is right there. I was going to have to go into Pythagorean theorem, but turns out we can just double that. So 6.4, is that right? Because it goes all the way across. All right, so let's walk through this one. Not quite clear, but most of you got a good chunk of it. So we're going to draw A, B, C, and I'm going to ignore the A and the C right now until the next step. Now I'm going to sketch the angle bisector, so I'm going to cut it such that it goes through something like that, and I'm going to mark the congruence. That's what it means to be an angle bisector. Now I'm going to put P anywhere on that angle bisector, so right here could be P. Now from that blue point, I need to go perpendicular to one of the sides. So I'm going to go like this and make a perpendicular. Now I'm going to do the same thing here. I'm going to go perpendicular like that. Right, that's the more complicated part. Now I should have said those are the things that you should label A and C at that point there and at that point there. Oh yeah.
Wait, I just drew it ended up being two right triangles. Why'd you angle those things?
There's our two right triangles. See the right angles there? But you
right-
did the right angles here.
Yeah.
Right. So the point is they have to be right at there, right there. Okay.
Be right there.
It says draw a segment from P to a side that is perpendicular to the side. So it's got to be perpendicular to the side, not perpendicular from P. Perpendicular there. Yeah, so that the diagram is, or the instructions need to be clarified, so my apologies. So why are these two triangles congruent? Angle, so yeah. HL, well, we don't know a side there or a side there. Angle, side, wait, angle, side, there we go. Angle, side, and let's see why. Because we have a right triangle, we have the bisecting, and then we have a reflexive property there. So what's now true about AP? Well, those two have to be congruent. Why? By CP/CTC. In fact, there's other things that you can say are congruent too. You can say that AB is congruent to BC. You also know stuff about other angles too. What else do we know? We know that this guy here has to be congruent to this guy here. So how do we say that as a theorem? If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle. Turns out the converse is also true. So we have to define what equidistant in this case means. Equidistant, and when we say like a point equidistant from a line, because line or point to point is not such a big deal. Line to line and point to line, you have to have two things. Number one, we need a congruence, but we also need perpendiculars. We need right angles. Because we have to approach, when I'm here, I have to approach this side, or a wall, or whatever it is, the street, I have to approach it at a right angle. Otherwise, it's not going to be the shortest possible distance to that place. So the converse of this is also true, and it says, if a point is equidistant from two sides of an angle, then the point, is on the angle bisector. These concepts here in our final moments of class. All right, so how far away is M from KL? So let's see where M and KL are.
Wait, did you grade that?
All right, so let's see. Here is M, and the converse says if, so M from KL. So how far away is M from KL? Well, that's right here, right? We know it's perpendicular. M approaches this side right here, KL, at a right angle. So that means it has to be 8. How far away is M? It's 8 units, so 8 feet, 8 inches, whatever. So how about M from JL? Well, it turns out, since that's congruent and that's a right angle, we can also, excuse me, thank you, JK, we can also say that's 8. So how about KM? How is KM related to this large angle right here? It is the angle bisector. How do I know that? Because we can say hypotenuse leg. We can say HL here. Here's hypotenuse, here's leg, and here's a right angle. So those two have to be, these two triangles are congruent, and since that's the case, that means these two angles are congruent. So therefore, to find out what X is, you just set it up like so. So X is 18, so that means the measure of angle MKL is already 54, right? MKL is already 54, so there's no finding there. But JMK is up there. How do we find out what that angle is there?